Okay, let's see if you get something similar to what I have. Well, the first thing, well, from 0 to 100, oh, I use 1 to 100, and then I cut this space into a total of 1000 samples. And after that, since this n is a NumPy array, I'm able to do something like this. So n powers 2, well, if that is a Python list, we can do that. But if it is a NumPy array, we can do that, and then all the values will be squared. Okay, and similarly I create another function that is for n log n, and after that for the solid line blue, I'm using that for the n square, and then for the dashed line red, I'm using that for the n log n. And after that I add two labels and I specify the legend to be on the upper left corner. Okay, so well, let's move on and we can talk about more about how we can choose part of the lines that we add legend to instead of adding legends to other lines. And that's interesting, right? And well, say I have 3 lines. Well, and if you see the textbook, well, by the way, that's the Lizard book, and then we have the original code here. And I find the original code is really hard to read, and even that's really hard to read for me. So I decided I want to rewrite this code, and this is the version I have. So I have 3 sine curves, and for the first sine curve, and then that is just a sine x, and for the next sine, I'm shifting that to the right side by a 1 pi, and then the next one, the y3, I'm shifting that to the right side by 1.5 pi. So exactly the same sine curve, but I'm shifting that to the right side. So I have a total of 3 sine curves. And now the question is, well, how do we want to plot them together? And here is the trick. Well, we put the y1, y2, and y3 into a NumPy array, and then we do a transpose. And after we do the transpose, if you want to get the shape of the transpose y1, y2, and y3, and we got a 1001, 3. And then, well, we know that this x is a NumPy array of 1001 points. And, well, in this one, y1, 2, 3, that is a 1001 by 3 matrix. So, well, for each x value, there are 3 y values. So we are plotting 3 lines together. Okay, so that is the trick that the textbook use. And after that, so that's the important part. So all those codes are just created to show the 3 lines, but what we are trying to do is we only want to add legends for 2 lines. And how do we do that? And say we have 3 lines, and then for the first 2 lines, and that is a slicing, so we are gonna do a slice, and then we get the index 0 and index 1, that they are the first 2 lines, and for the first 2 lines we add the legend first as second. Okay, so this is one way to do that. And another one is, hey, we can do that even easier. We just plot 3 lines, and then for the only 2 lines, we add the labels. So for the third one, I didn't add the label, and then if I'm doing a legend for the line without a label, and then the legend won't show that. Okay, so that's just an easy way for you to show multiple lines, and then you only add legends to part of the lines. Okay, and let's move on. And before we work on the next data set, and let me make sure that we understand what are the latitude and longitude. And I'm not a geoscience person, and I hope this plot can explain what are the latitude and longitude better than I can do without any visual aid. Okay, and let's move on, and we want to load the dataset of the California cities. And for this California cities, we do have a lot of information. We have the city name, and then the latitude, longitude, and then a bunch of the more things like the population, like the area, the size of the area, etc. etc. Okay, and then we first want to grab the latitude and the longitude, because if you want to plot the cities on the map, and then those are the important things. And after that, I also want to grab the population and the area. So, well, for the population and the area, they should be kind of correlated, but not always. Okay, and if we want to see the first 3 cities, and then we can see that. And after that, here is what we are going to do. We are going to create this visualization. So we have the longitude at the x-axis, the latitude at the y-axis, and then, well, for the size of the bubbles, I'm using the city area. And then for the population, I'm using the colors to show the population. Well, but one of the observation is for the population of those cities in California, well, the difference, it's really too much. So I decided that I want to apply a log scale to the bubble size just to smooth the size of the bubbles a little bit. So as you can see, that is log 10 of the population instead of using the population as the raw number. Okay, so let's see how can I do that. So first I specify the size of the plot, and then I'm doing a scatter plot. So longitude, latitude as a x and y axis, and after that, for the color, that is the log 10 of the population. And for the color map, I pick a colorful color map. And later we are going to discuss is that the best one to use. And then for the S, that is the size of the bubble, and that is the area. And then I add the X label, the Y label, the color bar, and then I'm specifying the color limitation to 3 and 7. So if it is higher than 7, and then I'm going to use the darkest blue. And then if it is lower than 3, I'm using the darkest red. And then I'm trying to put some limitation of the spectrum, and otherwise, well, there are some really small cities, and then the spectrum could be go really far. So this is the trick sometimes you want to do, especially you are plotting a dimension that you have the data varied really a lot. Okay, and we haven't finished yet, and we want to do the bubbles, and then I'm going to use the bubbles to visualize the size of the city. So I'm using the 100, 300, and 500, and then I want to create those 3 bubbles, and that is a little bit tricky, and let me tell you how I did that. So there are 3 values, 100, 300, and 500, right? And I want to create 3 legends. And what I did was I created scatter plot. And on that scatter plot, what did I really plot? I plot nothing, right? Because for the x-axis, there's nothing. For the y-axis, there's nothing. And then for the color, it's black. But don't worry, there's no x and y values there. So what am I plotting? Really nothing. But I want to have the label, and that's the important part. Even though I didn't plot anything, but I made a plot, a scatter plot, and then by using that a empty scatter plot, I'm able to add the legend, and that is really what I'm trying to do. So I'm adding the labels for those 3 empty scatter plots for now, so later when I'm doing the legend, now I can say, okay, there are 3 empty plots, no dots have been added, but those are 3 empty plots, and then using the labels of 3 plots, I can do my legend. So that is kind of a hack, but this is how you can do that. Okay. Okay, and then after we see that, and let me show you a map. So this is the map of California, and then comparing this map versus this plot, and then we can talk about something. Well, the first thing is the spectral, and for the spectral, one of the things I didn't like it too much is, well, it started from the blue, and then the teal, the green, yellow, orange, red. Well, the problem is there are kind of a little bit too many colors there. Well, for those colors, they kind of make sense because they are going from the the cold color blue down to warm color, which is red. So it kind of makes sense. But I'm still complaining that for this plot, probably we have a little bit more color than I really love to have. Okay, so in my solution, I say, okay, try the red, yellow, and green. Well, probably using that one, you can do a little bit better. Okay, and then for the next question, well, what observations can you make? Can you make on this plot? So, and remember, what is the size of the bubble? The size of the bubble are the size of the cities. So, where are the large cities? How this one? What's this one? That is LA, right? And LA is the largest city, and also that is the largest in the population because that is a blue bubble. And how about this one? That is right on the border. So what is that? That's San Diego, and that is another big city. And then the size, the color of the bubble is green, so it's here. So also a big city. And how about this one? This one, if I have to guess, I would say that's San Jose instead of San Francisco. But I can't. We don't have a way to overlap a bubble plot on a map yet, so I don't know. And you can see here there is a cluster of the cities. That's a Bay Area, and here is another cluster of the cities. And then in the inner Bay Area, for example, if you see this bubble, this yellowish greenish bubble, I believe that is Sacramento. Okay, so well, those are a little bit things we can talk about. Well, even though we have to compare this map versus this map to really help us find out what are the cities over there. Okay, and then let's move on and oops, I don't want to show you the answer key. And let's move on and do another exercise. And for this exercise, well, you're still going to use the latitude and longitude and the x and y coordinates, and use the bubble as the population as the bubble size, and then the area water percent as the bubble color. Okay, so well, using the area water percentage, you can get some idea on how dry California it really is. Well, if you have been to California before, especially in the winter, and you will see what I mean. Well, and probably you have also heard about the horror stories that there are a lot of the uncontrollable wildfire in California. Right? Okay, so spend some time and fill in the code, and I will go through my solutions in the next video.